The gut-associated microbiota is considered a superorgan that performs many activities in the human body and affects the mechanisms that regulate the functioning of the most human systems and organs. Bacteria are present in every section of the gastrointestinal tract, with the highest abundance in the large intestine. The process of shaping the intestine microbiota begins in utero and continues for at least the first 2 years of life. The first 1,000 days of life are believed to play the most important role in microbial programming. Disturbed microbiota composition, so-called intestinal dysbiosis, can result in abnormal activation of the immune and metabolic processes and induce the development of chronic diseases such as allergy, autoimmune, metabolic, or psychogenic diseases. The imbalance in the gut microbiota is also responsible for disruption of the gut-brain axis in the development of functional diseases. For me, the most important area of microbiome research in the possibility of influencing the gut dysbiosis and modulation of the intestinal microbiota, which is related to the prevention and treatment of diseases. In this respect, probiotics and their metabolites, so-called postbiotics, seems very promising. Probiotics are defined as live microorganisms which, when administered at the correct dose, have a significant health benefits to the host. They can improve gut microbiota dysbiosis and limit pathogenic bacterial colonization. They also have more specific effects: induce anti-inflammatory response, increase the gut barrier permeability, improve lipid profile and calcium absorption. Irritable bowel syndrome, IBS, is one of the most common functional gastrointestinal diseases, characterized by recurrent abdominal pain associated with changes in stool frequency and form. A pooled estimate of international IBS prevalence is about 10%, which means that every 10th person suffers from IBS. And although IBS is not a fatal disease, but it has a negative impact on patients' quality of life, due to the fact that it is a multifactorial disease of not fully known etiology. Treatment is symptomatic and not always bringing satisfactory results. It is supposed that the intestinal dysbiosis inducing disturbances in the functions of the gut-brain axis may be a main factor responsible for most of pathological conditions in IBS. Several studies have reported significant alteration in the gut microbiota that may promote the development and persistence of IBS. Significantly lower abundance of Lactobacillus, Bifidobacterium, and Helicobacterium prausnitzii was presented in IBS patients compared with healthy controls. Thus, modification of the gut microbiota composition by probiotics plays an important role in the treatment of IBS. Studies show that probiotic effectiveness in IBS is dependent on the number of strains used in probiotic preparation and the dose. A recently published meta-analysis of randomized clinical trials presented that supplementation with multi-strain probiotics can be superior in comparison with single-strain preparation in IBS symptom improvement. It seems that a daily dose of multi-strain probiotics should not be higher than 10 billions. A high number of active probiotic bacteria can induce over-fermentation of carbohydrates with gas production and discomfort in bowel habits. Finally, the length of probiotic therapy is also important, and as shown by the recently published meta-analysis of clinical trials, it should not be shorter than 8 weeks. In the randomized, double-blind, placebo-controlled study, we evaluated the effectiveness and safety of probiotic preparation, including non-biotic strains, in patients with diarrhea-predominant IBS. The patients receive a mixture of Lactobacillus, Bifidobacterium, and Streptococcus thermophilus strains or placebo for 8 weeks. The probiotic, in comparison with placebo, significantly improved the IBS symptom severity, especially the specific scores related to the severity of pain and the quality of life. After 8 weeks of treatment, the percentage of patients reporting an improvement in most symptoms was greater in the probiotic group. It is necessary to underline that the beneficial effects of probiotic supplementation was assessed with the use of 2 international scales: the IBS Severity Scoring System, IBS-SSS, and Global Improvement Scales, which greatly improves the value of this study. Probiotic bacteria, to have beneficial health effects, should survive and multiply in place of their action. It means in intestines. Probiotic preparations containing species of 3 genus, Streptococcus, Lactobacillus, and Bifidobacterium, create such opportunities, which was confirmed in experimental studies of the gut model. Physiologically, Streptococcus species are present in the upper part of the small intestine. So, Streptococcus thermophilus, which is often used in multi-strain preparation, multiply in duodenum and create specific anaerobic conditions, lower pH, which allows for the multiplication and activity of Lactobacillus species in small intestine. Bifidobacteria reach the large intestine, the place where they exhibit functional activity. Just the combination of these 3 genus shows a synergistic effect. I believe that microbiome research has a huge future. When I started my adventure with the world of gut bacteria 30 years ago at the Czech Academy of Sciences in Prague, I knew that the intestinal microbiota play a great role in the development of the immune system, and intestines are the main immune organ. At that time, the term probiotics was used as a historical term associated with Mierczynkow, the father of probiotics. Now, we currently know that the microbiome is responsible for our health. Modulation of the microbiome by probiotics, prebiotics, and postbiotics is one of the main directions of supporting the treatment of increasing number of chronic civilization diseases.